Hello students, in this video we are going to understand how to use normal distribution table and solve problems based on this normal distribution table. So this is the normal distribution table in front of you where we have Z values, which is your standardized score, on the left column and also on the top row. So whenever we are looking for, say for example, Z equal to 2.24 and this corresponding area will be the values inside the table. And Z equal to 2.24, how you will look at it is, you will first go for 2.2 and then 0.4. So 2.2 and 0.4, so 0.4875 will be the value. Now we will use this table to solve the problem. Here is the problem. So we have a training program designed to upgrade supervisory skills of production line supervisors. Because the program is self-administered, supervisors require different number of hours to complete the program. A study of past participants indicate that mean length of time spent on the program is 500 hours. So given that the mean is 500 hours and that this normally distributed, also they have mentioned that it is a normally distributed random variable, and the a standard deviation of 100 hours. So the clearly, if you read this, they have discussed, they have given you three informations. The mean is 500 hours, it is a normally distributed random variable, and it is all the standard deviation is 100 hours. Also there is no discussion about a sampling process here. So we can safely assume that this they are talking about is for the population. In this normal distribution, the formula, there is a small difference between the formula for normal distribution for population and normal distribution for sample. So this is a case where we are discussing about population. So the example, the first question is, what is the probability that a participant selected at random will require more than 500 hours to complete the program? So our standardized score formula is Z equal to X minus B upon sigma. Now here, because we want to find out 500 hours related Z value, our X becomes 500. They are already given the mean is 500 and mean of the population is shown as mu. So mu is 500. The standard deviation for the population is sigma, which is 100. And when we put these values here, you will get Z equal to 0. So when you get Z equal to 0, basically you are here. And if you look at the table, when you know that you are exactly at the center, and whatever you want is more than 500 hours. So our area of interest, area under the curve of our interest is this shaded area, this colored area, because this is more than Z equal to 0, which represents mu equal to 500. Sorry, X equal to 500. So this area we know that it is 50%, and hence our answer is 0.5 or 50%. So probability that you will find a person selected at random requiring more than 500 hours, this is more than 500 hours, is equal to 50%, 0.5. Okay. Let us look at the second problem. What is the probability that a candidate selected at random will take between 500 and 650 hours? So now we have two limits between 500 and 650. So whenever this is there, we have to first calculate the values at these 2 points, the Z values at these 2 points. We already know that for at Z equal to 0, we for X equal to 500, we get Z equal to 0. And let us calculate for 650. 650 minus 500 upon 100, so you will get 1.5. So our area of interest is here, right? Here z equal to 0 and z equal to 1.5, and between 500 and 650, so between z equal to 0 and z equal to 1.5 is the area of my interest. When I go to my table, you will see for 1.5 we have answer 4.4332. The area is 0.4332. So our answer is, this area is 0.4332. So our answer is, the probability between of finding a person taking between 500 hours and 650 hours is 43.32%. Now the next one again, what is the probability that a candidate selected at a random will take more than 700 hours? So first step is to find out what is the value of z at 700 hours, and we got it 2. Then when you draw the diagram, you will understand that because you are talking about more than 700 hours, this is the area of my interest, 700 hours on the right side of the 700 hours. We have already calculated z equal to 2. When we go to the table, we find that z equal to 2 is, the area is 0.4772. But what is this area? This is between z equal to 0 and z equal to 2 is 0.4772, and we want the area which is outside z equal to 2. So we need to subtract this area 0.4772 from this entire area, which is 0.5. So the area under this side is 0.5 minus 0.4772. So we get 0.0228. So the answer is that the probability that you will find a person randomly selected taking more than 700 hours is 2.28%. Okay. The fourth variation is, suppose the training program director wants to know the probability that a participant chosen at random would require between 550 and 650. So again we have two limits, but now these limits are here. So for both these x values, we will have to find out for z values, and you will see the z values you calculate, right? It will be 0.5 for 550 and 1.5 for 650. So when you draw the diagram, you will see that between 0.5 and 1.5, this is the area we want. So to get this area, basically we have to do now, for 1.5 you will get this total area, right? This total area for from the table, and for zero point 0.5 you will get this area from the table, and when you subtract from this entire area, this area, you will get this area. So that is what exactly we have done here. 0.4332 is for 1.5, 0.1915 is for 0.5, z equal to 0.5, and the difference is 0.2417, which is 24.17. So our answer is, the probability of finding a person taking requiring time between 550 and 650 hours is 24.17. Now let us look at the fifth variation. What is the probability that a candidate selected at random will require fewer than 550 hours? So now we have to first find out what is the value of z at 550, which is coming 0.8. Now from the table we will get this area. This area is available from the table. Let me take you to the table and you will find out the value corresponding to 0.8 is 0.2881. So what we have got is this area, this between this and between this, that is on the right side of the z equal to 0 and z equal to 0.8, between this is available to us from the table, but we want this entire area because for us what is the requirement? Lesser than 580. So this total area is required, so obviously we have to add 0.5 to this area to get the total value. So we will get it at 0.2881 plus 0.5, 0.7881. So our answer is that probability of finding a person taking less than 580 hours is 78.81%. Now the another variation is here. What is the probability that a candidate chosen at random will take between 420 and 570 hours? So again, we have to find out z values for the two, 420 and 570, and for 570 it is zero point 0.7, for 420 it is minus zero point 0.8. Now how to handle this minus zero point 0.8? So we should know that this particular normal curve is symmetrical. That means whatever is on the right side is same area will be there on the left side. So to find out the area between z equal to 0 and z equal to minus zero point 0.8, we can find out from the table the area between 0 and plus zero point 0.8, and that will be this area, because the area will remain same on both sides of the mean. So with this logic we will get the from table for 0.7 we will get value, and for 0.8 also we will get value, and those values are 0.2580 and 0.2881. So when we add them we will get 0.545461. Why we need to add? Because here we can clearly see that to get our area, total area between the two, we need to add this area and this area. So this is how we will get the answer to the question, the probability of finding a person selected at random taking hours between 420 and 570 as 54.61. So this completes all the variation which is uh, you know uh, for the questions which is based on the normal distribution curve with population. When we are discussing about population, when we discuss about sampling, there will be a bit difference which we will see in my next video. Thank you.